All right, good afternoon, or morning, or evening, whenever you're looking at this. Uh, I have a date today of April 20th. It's around 5 o'clock, and I know this is dated April 17th. I'm just using this a few days behind of where we were at with the AP Live from YouTube. So I'm just going to kind of go over L'Hopital's rule. L'Hopital's rule is an important rule when you're doing the limits, another way to do it when you're doing the limits. When you have ratios that tend to go to 0 over 0 or infinity over infinity, which we call the indeterminate form, there's a rule that we can use, L'Hopital's rule, but there are certain stipulations that we need to have when we're doing this. One of the stipulations, and the realistically only situation, is that when you have the limit as x goes to a value a of the numerator and the limit as x approaches a of the denominator, that they both go to 0 or infinity. Then, since L'Hopital's rule can be applied, you will take the derivative of the numerator and then the derivative of the denominator, and then check to see whether or not the limit as x approaches that a value still continues to go to 0 or it continues to go to infinity. If it does not and it comes up to a value, then you're done, and that's the limit. Sorry, I had to itch there, so I paused the video just a little bit. So what we're looking at is we have to take the limits of the numerator and denominator. This is not taking the derivative. We're not going to use the quotient rule. This is using in limits, okay? So let's take a look at the first one. The limit of x approaches 0 of sine of 2x over the sine of 5x. Now, basically when we have done limits before, I'm going to zoom in a little bit on this. Let's see if I can focus it up. Okay, that's a little bit better. We would do direct substitution. And so sine of 2 times 0 over the sine of 5 times 0. And the sine of 0 over the sine of 0 is 0 over 0, which is the indeterminate form. So direct substitution doesn't work. Let's try the limits as x approaches 0 of the numerator. So if we wanted to check L'Hopital's rule, we have to do this process. So direct substitution doesn't allow you to do L'Hopital's rule. Okay? That is going to equal 0, which is going to equal the limit as x approaches 0 of the sine of 5x. Okay? So that does work. Okay, so that shows, therefore, these three dots are therefore L'Hopital's rule applies. Okay, so if you are doing this on the test and you're doing that, you must state in a free response question that L'Hopital's rule applies. Since L'Hopital's rule applies, we can therefore take the derivative of the numerator. So sine of 2x is going to be the limit as x approaches 0. Always write out as much as you can. So the derivative of the outside, we got to use chain rule. Derivative of the outside is cosine, keep the inside. And then we're going to multiply it by the derivative of the inside, which is 2. Down here, it's kind of the same thing. Derivative of the outside is cosine of 5x times the derivative of the inside, which is 5. The limit as x approaches 0. So now you're looking for the limit as x approaches 0 of this. The limit as x approaches 0, if I direct substitution, that's going to be 2 over 5. So we're going to take the look at the limit. So when I take a look at the limit as x approaches 0, as x approaches 0 of 2 cosine of 2x, and I get 2 cosine of 2 times 0, which is cosine of 0, which is 1. That doesn't go to 0 or infinity, so it must be true that the bottom does not as well. So it might be undefined. If that bottom limit goes to 0, 2 divided by 0 would be undefined, but it goes to 5, so that's my derivative. Okay? All right, let's do the second one. That other one you can do. You can continue to do it. So we're checking to see if the limit as x approaches 0 of the square root of x plus 1 minus x over 2, or 1/2 x. If I plug in 0, I get square root of 1 minus 1, which is 0. Minus 0 is 0. Let's see if the limit as x approaches 0 of 5x squared is 0. Yep, that is. So we're going to take the derivative. So therefore, L'Hopital's rule applies, or you can use L'Hopital's rule. All right, derivative of the top. Now, derivative of square root of x, you should know, is 1 over 2 square root of x. You've done this several times. You have seen that before, and anytime that you're doing the derivative of the square root of something, it's always going to end up to be 1/2 times, or 1 over 2 times the square root of whatever's inside. Now, if you need the chain rule, make sure that you have the derivative of the inside. So the derivative of the inside, in this case, x plus 1 is still 1. So we're good on that. So this would be 1 over 2 square root of x plus 1. The derivative of 1 is 0, and the derivative of x over 2 is 1/2. Derivative of 5x squared is 10x. So we are still taking the limit. Please write that out. All right, so we're now checking the limit as x approaches 0 of 1 over 2 times 1, square root of minus 1/2. Oh, that's 0. And the limit as x approaches in 0 of 10x is also 0. So I can do it one more time. I can take the derivative of this one more time. So the derivative of that one more time, the bottom is pretty easy. That's going to be 10. On the top, derivative of this is going to be 0. Derivative of this is going to be, and if you haven't done that one before, that is going to be, I'm going to do it this way, 1/2 x plus 1 to the negative 1/2 power. All right, so the 1/2 stays out there. We're going to multiply it by the negative 1/2. We're going to take the inside and drop this by 1. And we're going to multiply by the derivative of the inside, which is 1. So this is negative 1/4 of x plus 1 to the negative 3/2. Now, I leave it in that form. I can change it. I don't need to, because when I direct substitution, notice I'm going to get 10 on the bottom. And when I get something other than 0 or infinity, L'Hopital's rule is done. So once I get this, if I plug in 0, I get 1 to this, which is 0, or excuse me, 1 times 1/4 is negative 1/4, times 10 is negative 1 over 40. Okay, now if I were to graph that, if you looked at 0, that would go to negative 1/40. Okay, so this one does. I'm going to kind of speed through this one. So limit as x approaches infinity. You would have to go through the limit part. I'm going to take the derivatives. And reminder, this is 4 times 1 over 2 square root of x, which is going to be 2 over the square root of x, which is the square root of x over 2x. We're going to go that route, okay? So if I plug it in, I get the square root of infinity, which is infinity over 2 times infinity, which is still infinity over infinity. So what I'm going to do is I'm going to take the derivative of this. So this still gives me the limit as x approaches infinity. All right, so I've done L'Hopital's rule. I'm just kind of working ahead. This derivative would be 1 over 2 square root of x. This would be 2. Oh, that works out. So we get 1 over 4 square root of x, because that attaches to that. And if we look at the limit as x approaches infinity, get rid of that. So we have 1 over, oh, square root of infinity is infinity. 1 over a huge number. And we talked about limits as 1 over x. Derivatives goes to 1 over x, and that is 0. It goes to 0. Remember when we were doing derivatives of top, or not derivatives, limits with polynomials and looking for horizontal asymptotes. That's where we get those asymptotes from, is reminder for those. Okay. All right, so let's take a look at this one. Limit as x approaches 1 of 10 to the x minus 3 f prime of x, which is going to be 10 to the first minus 3 times, f of the first, which is going to be 2. Oh, that's 6. Excuse me, 10 minus 6, which is 4. So the numerator is going to be 4. L'Hopital's rule does not give you this. So we just are going to take the limit as x approaches 1 of f of 1 minus arctan of 1. And so this f of 1 is, that's 1 minus the arctan of 1. So it's the inverse tangent of 1, which is in quadrant 1, where the tangent is 1, and that is at pi over 4. So your answer would be 4 over 1 minus pi over 4, which is a totally acceptable answer. If you wanted to rationalize, you get 4 over 4. And if you wanted to go a step further, you get 16 over 4 minus pi. Any one of those answers is acceptable. All right, so that is L'Hopital's rule in a nutshell. Go back through this. If you have any questions, email me. And I hope everything is good with L'Hopital's rule.